The ancients believed that four basic elements constituted their environment and shaped the world around them: earth, water, air, and fire. In 1988, a fire raged through Yellowstone National Park, charring nearly 750,000 acres of timber. It's quiet today in Yellowstone. The flowers and grasslands are returning. Seedlings have begun the long process of restoring the timberlands. Wildlife is abundant, and the great grizzlies have reestablished themselves in the remote lands of the park. We are witnessing nature's most amazing quality, its durability. Harnessing the four elements, the clay pipe industry is producing a product that is not only protective of nature, but like nature, is incredibly durable. Even before 1872, the year President Ulysses S. Grant signed the authorizing legislation into law, and the region of the Yellowstone became our nation's first national park, a manually operated extrusion press was in use, producing our nation's first clay pipe. At that time, Alexander Graham Bell was 4 years away from his famous telephone call to Dr. Watson, and 9-year-old Henry Ford would not put his Model T on the road for another 36 years. By 1900, most of the major cities in the United States had clay pipe sewer systems. Trenches were made by pick and shovel, and the pipe section were laid manually. Using crude methods, the joints were then formed in the trench. And though water entered the line through leaking pipe joints, it was actually considered a benefit to the hydraulic operation of the system. Thus, the old adage, dilution is the solution to pollution. Though mastics, asphalt, cements, and mortars were widely used as jointing methods, they proved to have a limited durability. During this period, pipe joints went untested. Line acceptance tests were accomplished by lamping the line. If light could be seen from one manhole to another, the line passed inspection. These practices would continue for another 50 years. Then, when sewage treatment facilities were developed and the extra water became undesirable, efforts were stepped up by the clay pipe industry to produce jointing systems that would minimize infiltration. In the 1950s, when elastomeric material became available, the clay pipe industry's priority was to develop factory-applied compression joints. These new methods were successful and were quickly adopted by the sewerage industry. Clay pipe began leading a new era in sewer line performance. Other materials were also being used in sewer construction: concrete, cast iron, steel, wood. Good materials for many uses, but as sewer pipe, all experienced deterioration. Later, asbestos cement, with its lighter weight and longer length, showed promise. But this pipe was also weakened by the effects of acid. Although coatings were applied to the interior of the pipe in an attempt to protect it, these measures merely delayed the inevitable. But more importantly, the workers manufacturing the pipe were being exposed to the hazards of asbestos fibers. Eventually, certain plastics, such as reinforced plastic mortar, which was originally developed for the space program, were introduced into the pipe industry and hailed as the end-all answer for sewer pipe. Unfortunately for them, and many communities where this space-age pipe was installed, the American pipe dream turned out to be just that, as failure after failure was reported. One community discovered that polyethylene pipe used in their sewers not only failed to operate effectively, but now is likely to be a financial and environmental burden for years to come. Now, environmental problems, chlorine pollution and dioxin contamination linked with PVC materials, have exposed the dream for what it is. Some of the most serious allegations against polyvinyl chloride, or PVC, stem from the increasing evidence of long-term health and environmental damage caused by persistent chlorinated compounds. Since its beginning, the clay pipe industry has continued to manufacture quality pipe while making significant improvements. The clay pipe are now larger, longer, and stronger than ever before. Factory-applied compression joints allow infiltration and exfiltration limits to be reduced, thereby keeping sewage in the pipe and unwanted groundwater out. Field research to evaluate and develop new bedding systems continues to increase the speed of pipe laying while allowing pipe to be installed in deeper trenches. The NCPI toolbox, developed and introduced by the clay pipe industry, enables designers to select efficient trench load designs, cost-effective bedding systems, accurate hydraulic solutions, and to make economically and environmentally sound choices based on the life expectancy of various products. Although it would be a gross exaggeration to say that public sewers in the United States are in danger of imminent collapse, it can and does happen. In the past, our nation has made some poor choices by putting short-term costs before long-term economics. But that was then. America had neither the experience nor track record of any pipe materials. Today, there is no excuse. To quote Pat Choate, author of American Ruins, "If we can't afford to do it right, can we afford to do it again?" In order to construct an efficient and durable sewer system, several important conditions must be met. First, we need a strong commitment to permanence. Even if the political leaders are able to raise the enormous sums they say are needed for sewer systems over the next several years, there will be a strong tendency to get the most pipe in the ground for the least amount of money. In short, to build the cheapest sewer system possible. We need a change of attitude. This planned obsolescence has created many of our present problems. We must begin to think of the future cost of repair and replacement of inferior sewer systems and the damage they can cause to the environment. We must see past the short-term dollar cost of a project. So, with a commitment to permanence, we now need to select the best product for our system. The most common problems for clay pipe sewer systems in the early days were leakage and tree roots. The clay pipe itself, however, remained in excellent serviceable condition. In fact, hundreds of clay pipelines have been in continuous service in the United States since the late 1800s. Clay pipe was then, and is now, the best material for the job. While a commitment to permanence and good product selection are essential, proper design and installation are equally important in order to construct an effective and efficient sewer system. Many good engineering designs have been ruined by careless installation procedures, and even the best materials can be damaged. The engineer makes detailed calculations and design decisions that will allow the pipeline to perform effectively for many years with a minimum of maintenance. When designing a system, the engineer must consider the capabilities, the differences, and the limitations of the type of pipe specified for a particular project. For example, it is not economical to install clay pipe in bedding systems designed for flexible pipe. With clay pipe, the pipe itself is a structure, and the contractor simply installs a bedding. Now, with flexible pipe, the contractor must build a structure around the pipe to support it. Proper inspection and testing of the system is the safeguard which assures that the design, from the drawing table to the trench, is adhered to. Simply listing these required acceptance tests in the specifications means little if they're not enforced. A strong commitment to permanence, selection of the best product, proper system design and installation, and proper inspection and testing all are vital to making an efficient sewer system which is durable and protective of our environment. When suitable clays are extruded into pipe and vitrified at 2,000 degrees Fahrenheit, the individual grains of clay fuse together into a solid material which is both chemically inert and abrasion resistant. Vitrified clay is rock hard and can handle high water velocities and waterborne grit with no apparent damage. Of all the available sewer pipe materials, clay pipe alone has a track record that demonstrates durability. It alone has the chemical inertness to handle hostile, effluent, and aggressive soils. It alone is made from an abundant natural resource, and it alone has an indeterminate lifespan. With the great advances in correcting the problems of the past, there is now an opportunity to make sound choices which will have long-term benefits. The clay pipe of today is far superior to the clay pipe which bested the competition in the past, and it is better than any material to come along since. Why? One word: durability. Today, it is possible to build a sewer system which is protective of the environment and will last for more than a century. But we must choose value over cost and performance over convenience. We may not have an opportunity to make these choices again. The choices we make today will affect generations. Our choices must be good ones. Clay pipe is a good choice.